Multiple regression, dummy or indicator variables, including Excel output. Hi, I'm Dr. Nick, and in this video I'm going to explain about the use of dummy variables in multiple regression. This video follows on from multiple regression overview. This video is about how we can include nominal or ordinal data in a multiple regression and how to interpret the coefficients. I will give one extended example and then some other illustrations. Check in the description below for more videos about multiple regression. Some may be special content for channel members. I will use the same data set I used in the ANOVA video about household incomes and qualifications. This is an example based on real data about people's annual incomes and qualifications. There are details about it in the description below. For each person, we have data about their level of qualification, their age, and their annual household income. There are 300 observations. First, we can create a simple regression showing the relationship between age and income. Income is the dependent variable and age is the independent variable, so income goes on the vertical axis. There is an upward slope. This makes sense as you would expect people to earn more as they get older. The regression model is income equals negative 52,800 plus 2,600 age. The coefficient for age tells us that for each year older a person is, all other things being equal, we would expect their household income to be higher by about 2,600. We can also use the model to make a prediction. A person who was 30 years old would have an expected income of negative 52,800 plus 2,600 times 30, which equals $25,200. Now say we wanted to see what the effect of having a degree is. We have that data recorded in our data set, so we can use it now. We can put in a dummy or indicator variable to say whether the person has a degree or not. The value for the variable degree is 1 if a person has a degree and 0 if they do not. The regression model we get is income equals negative 58,200 plus 2,700 age plus 34,300 times degree. The coefficient for degree tells us that if a person has a degree, all other things being equal, we would expect their household income to be higher by about 34,300 than a person of the same age without a degree. Using this model, we would predict that a person who has a degree and is 30 years old would have an expected annual household income of negative 58,200 plus 2,700 times 30 plus 34,300 times 1, which equals $57,100. Using this same model for a person who is 30 without a degree, the expected income would be $22,800. That is how a single dummy or indicator variable works. We can have multiple indicator variables. In our data set, we actually have 4 levels of qualification: none, school, vocational, and degree. In the ANOVA video, we found that there was a statistically significant difference in mean incomes between some of the groups. Using multiple regression and indicator variables, we can make a model that incorporates age, a measurement variable, as well as the different levels of qualification in order to explain or predict income. We need to have a dummy variable for each of the different qualification levels but one. There are 4 levels, so we need 4 minus 1, which equals 3 dummy variables. The indicator or dummy variables are school, vocational, and degree. For each person in the database, they will have at most 1 in one of those 3 variables. If they have all zeros, then that means that they have no qualifications, which is the 4th level of the variable qualification. I used if statements in Excel to create my dummy variables. You can see them here. Here are some examples. Tussie has a degree, so there is a 0 for school and vocational and a 1 for degree. Helen has no qualifications, so there are zeros in all 3 columns. And this is the output from the regression using Excel. We write the model as income equals negative 74,400 plus 2,800 age plus 18,100 school plus 18,200 vocational plus 46,500 degree. You may have noticed that the coefficients for school and vocational are just about the same. We can see in the box plot that there is little difference between these two groups. For a 30-year-old with no qualifications, the expected income is negative 74,400 plus 2,800 times 30. Each of the other terms has a zero value. For a 30-year-old with vocational qualifications, the expected income is negative 74,400 plus 1 times 18,200 plus 2,800 times 30, which equals 27,800. The values for school and degree are zero. You can also combine the dummy coefficient and the constant to express the model as four equations like this. These are the equations shown on a graph. There are only 3 lines, as the equations for school and vocation are pretty much the same. You can see that the lines are parallel. This model assumes that the increase by age is the same, regardless of the qualification level. This is possibly not a valid assumption, but we will deal with that in another video. Here are some more examples of the use of dummy variables. In this example, the dummy variables corresponded to different levels of qualifications. This was ordinal data. Other instances where dummy variables are used include gender, ethnicity, or marital status. For a model regarding car prices, you might have a dummy variable for automatic or manual transmission, or you might use a dummy variable for whether it was imported or not. In analysing experimental data, you might use dummy variables to indicate if the observation is in a treatment or control group. If you are looking at outcomes of treatment of hand injuries, a dummy variable would be used to indicate if the injury is in the dominant or non-dominant hand. When analysing customer behaviour, you might wish to indicate if the shopper was in person, click and collect, or delivery. As there are 3 alternatives, you would need 2 dummy variables. If you use a regression model for time series data that has a seasonal component, then you would have a set of dummy variables to indicate the month or quarter of each observation. This video has been about dummy or indicator variables in multiple regression. If you have other aspects you would like covered or you have questions, please put in the comments and I will see what I can do. Please like this video, subscribe, but most of all join the channel, especially if you're using our videos in your teaching. Help the channel grow and help me help more and more people like you and your students. Joining the channel also gives you access to more helpful videos like these. I am truly grateful for my channel members who help make these videos possible. I am especially grateful for my super supporter Ian Sim. Thank you.